If you've ever taken an online course, you know the feeling. You click into week 1 and you're met with a vertical list, video files, a stack of PDFs, and a discussion board link. Instructional designers refer to this as atomistic design. It is an architecture where the learning process is broken down into isolated, separate events. This format is a direct artifact of the physical classroom. In a lecture hall, a professor talks for an hour, assigns reading for homework, and gives a quiz on Friday. But when you map that structure directly onto a screen without adapting it, you create severe cognitive fragmentation. You're constantly jumping between a video player, a block of text, and an assessment tool, trying to stitch the underlying concepts together in your own head. This constant context switching exhausts working memory. It directly contributes to the low engagement rates and poor knowledge retention that plague digital education. Using a learning management system as a static delivery mechanism for files sabotages the potential for actual learning. The countermeasure to this fragmentation is holistic learning design. Instead of siloing tasks, a holistic approach weaves absorbing new content, applying skills, and connecting ideas into a single, uninterrupted flow state. Notice the inner circle of this framework. It identifies 4 vectors of a learning experience: cognitive, emotional, behavioral, and social. The outer dashed ring shows how learning activities and social interactions must completely enclose the user, integrating all 4 dimensions at once. Engineering this kind of environment means abandoning rigid, linear planning models and adopting an agile, iterative approach known as design thinking. Consider the challenge of transitioning a dense university course on French and Italian Renaissance literature to an online format. In the original classroom version, students watched a 45-minute lecture and then had to independently read and interpret a highly complex PDF text. When students were asked about this workflow, they reported that processing the critical readings on their own was overwhelmingly difficult. The design team identified the root cause, the split attention effect. A student reading a literary piece constantly has to break their flow to check separate documents for definitions or reference notes. This rapid context switching pushes cognitive load into the danger zone, destroying reading comprehension. Uncovering this exact bottleneck was only possible because the design team spent time actually talking to students, the crucial first step in the design thinking process: empathy. Fixing the split attention effect became the structural priority for the entire digital curriculum. To solve it, the designers had to overcome functional fixedness, the systemic trap of using new, advanced digital tools to perform the exact same outdated workflows. They stopped trying to figure out how to make a slightly better PDF. Instead, they used what-if statements to break their mental models. They asked, what if the supportive information from the lecture was injected directly into the reading material at the exact moment the student needed it? The solution was an interactive hypermedia document. This structure collapses time and space, providing definitions, artwork, and hints directly inside the text block. Effective digital education treats technology as a tool for embedded cognition, moving past the limitations of file delivery. The team built a tangible wireframe prototype. Notice how it handles the absorb phase, grounding users in the reading task. It actively integrates the do phase, allowing students to manually trigger supporting media during difficult passages and self-assess in real time. Using a low-fidelity, rapid prototype, let the team test the cognitive flow before writing any actual software code. Testing confirmed that putting the support resources directly adjacent to the text successfully mitigated the split attention effect. Visualizing the architecture proves that separate reading, lecture, and quiz elements can be fused into a single cohesive space. This is the final reading interface for the Renaissance literature course. The split attention problem is resolved. Audio commentary and comprehension exercises sit directly beside the core content. But optimizing for cognitive load addresses only the mechanics of the task. For students to persist through challenging content, the design must also address their emotional investment. This is where designers utilize a pedagogical wrapper, a structure that secures the edges of a learning activity. Here is the wrapper used by the instructor. Before the reading even begins, learners see an introductory video and a specific explanation of the goals. This introductory layer establishes the historical stakes. It hooks the learner emotionally and lays out a clear path for the upcoming challenge. The back end of this wrapper is a structured, instructor-moderated follow-up discussion forum. This post-reading debrief covers the connect phase of learning. It forces students to take their individual interpretations and synthesize them socially with their peers. Pedagogical wrappers bookend the core task, elevating what would be a solitary reading assignment into a continuous, immersive experience. Bringing back the 4 dimensions of learning reveals why this redesign works. The interactive text explicitly serves the cognitive and behavioral quadrants by embedding actions and information. Meanwhile, pre-brief videos and forums satisfy the emotional and social quadrants. Targeting the intersection of these 4 dimensions provides a structural foundation for the kind of deep learning and behavioral transfer observed in this redesign. A disjointed list of separate files in a folder cannot generate that kind of overlap. Modern instructional design requires looking past content delivery. It requires the deliberate engineering of continuous, multidimensional cognitive environments.